If you look closely at the Lake of the Woods, you may notice these two strange vortex-shaped features which are found in the lake. One of them is comprised of islands, with Painted Rock Island in the center. The other one is partially comprised of islands and partially attached to the mainland, and it is centered around the small settlement of Morrison. So in today's video, let's cover how these two vortex features formed. So these features are found in the Canadian Shield, and much like most of the rocks of the Canadian Shield, their history is very ancient. To truly understand how they formed, we have to go back 2.8 billion years ago. This long period, known as the Archean period, saw the creation of Earth's oldest rocks that are still around today. These regions of old rocks are known as cratons. And one of these cratons pictured on this map has the abbreviation SU. It is known as the Superior Craton. This Superior Craton covers a vast area of more than 1.5 million kilometers squared, and it spans from Labrador to South Dakota. However, obviously, this craton did not form the size that it is today. Instead, it built up in a process known as accretion. In accretion, blocks of crust, known as terranes, break off the subducting plate and get added to the continental overriding plate. What this does is effectively grow the continental plate. And so in the Archean period, there were many of these terranes that all got accreted together and formed the vast Superior Craton. All of these terranes have a different formation history and composition of rocks. The specific terrain where our vortex formations are found is known as the Western Wabigoon terrain. So now let's discuss the geology of this terrain specifically. Most of these Archean terrains formed as island or volcanic arcs, essentially the location where a subducting plate creates more magma, which is able to create a large arc of volcanoes. Think the Ring of Fire like Japan today. The rocks of our Western Wabigoon terrain formed during 4 different volcanic periods, which spanned 2,780 to 2,720 million years ago. These 4 volcanic periods grew 4 different volcanic arcs, which eventually grew into one thick terrain. So essentially, this period before 2.72 billion years ago would have the Western Wabigoon terrain formed as a landmass, but not accreted to any terrains yet. This was until the next period, which lasted from around 2.72 to 2.68 billion years ago. This was the period that built up the Western Superior Craton into essentially what it is today. For our Western Wabigoon terrain, it started by colliding and accreting to the terrains nearby to it, such as the Winnipeg River terrain and the Marmion terrain. However, eventually all the terrains in the area would accrete and form the craton. It is in this period of accretion that our features formed. Basically, this extended period of collision and compression led to the formation of 2 distinct layers of rock. One of them was of newer volcanic igneous rock and formed a layer roughly 5 kilometers thick, and that's the green on this map. The other layer was found lower down in the crust, and it was the older volcanic rocks, which was then metamorphosed into gneiss due to extreme heat. However, these 2 layers would not remain distinctly separated. Instead, this collision process also formed what are known as dome and keels. Dome and keels are a formation unique to this Archean period. This is because they can only form when there is little to no tectonic activity, and during our Archean period, only the beginnings of tectonic plates were forming. So, instead of the convection in the mantle causing the tectonic plates to move, it instead caused magma to move upwards into the crust as diapirs, which bent the crust upwards into a dome, or it caused the magma to sink down and form features known as keels, where the crust actually sinks further into the mantle. This entire process is known as vertical tectonicism. This is compared to the horizontal tectonicism of today with the tectonic plates. For our Western Wabigoon terrain, you can directly see how this dome and keel formation affected the rock composition. Here we have these long areas in between the domes, which are composed of rocks known as greenstones. In between these greenstone belts, you can see the domes. These domes are composed of either the igneous rocks, which formed from the magma that uplifted the terrain, or the gneisses of the lower crust, which got uplifted by the magma. It all depends on how much was eroded in that location. So this leads us to what our formations truly are. They are domes. Specifically, these domes are known as anticlinal or plunge domes, where the layers of rocks would have been uniformly uplifted in a roughly circular shape. As you can see from this diagram, we have these circular layers of rocks. Another famous example of a plunge dome is the Richat structure, or the Eye of the Sahara. This structure has many different layers of rocks that were all uplifted into a dome feature. So that is how the Painted Rock and Morrison domes formed. They represent 2.7 billion year old gneiss that was uplifted by magma during the accretion of the western Wabigoon terrain. But of course, our story does not end here. These domes have experienced more than 2.5 billion years of erosion. This has caused the modern day rocks of the domes, which were miles below the surface in the past, to be exhumed or revealed to the surface. Not only this, but the erosion, primarily the glacial erosion, have caused these domes to become mostly flat, with just a few small hills in some places. And of course, in other places, the glaciers have eroded the rocks to below the lake level. So we are basically seeing these domes at a perfect point geologically, where some of the crust is above the lake level and some of it is below the lake level, which creates the interesting pattern that is visible. Another feature you have probably noticed if you've been looking closely at these domes are the very clear rings between some of the rocks. This is especially apparent in the Morrison dome, where we have these ringed features that are filled with water and divide up the dome into several different sections. So what are these features? Well, they are lineaments. I mentioned what a lineament was in my previous video, but they are essentially the surface expression of a weakness. And in this case, it is the layers between the rocks. For example, here's a diagram which shows these layers of rocks, and our features are essentially the black lines between these different layers that were weaker, and so they were eroded more easily. Finally, the last feature I want to discuss are the red lines on this map. These are fault lines. More specifically, they are strike-slip fault lines, where both sides of the crust move in opposite directions along the fault line. This, of course, makes the fault line weaker, and so it got eroded more easily to below the lake level. Today, you can very clearly see where these fault lines are by just looking at how they divide the islands up by water. So this has been how these domes have formed, through a combination of horizontal and vertical tectonics dating 2.7 billion years in the past, and over 2.7 billion years of erosion. Today, these features are in a beautiful area around Lake of the Woods. Even though they are not visible from the ground, we can still appreciate them on satellite view. But that's going to be all for today's video. If you learned something new, please subscribe, and if you have any questions, leave them in the comments below. I will see you guys in the next one.